So what are the key points from this lesson? Well, there are two of them. And the first one is the whole idea of being able to calculate the expected profitability. And it all rests upon a couple concepts. The first is that we can calculate the expected units that we're going to be able to sell, and that's calculated by looking at the expected demand and subtracting out the expected units short. And we use that same equation when we determine the number of units that we expect to be sold at a salvage value if we allow a salvage value G. And the second thing is kind of tied to this, and that's the idea of the whole expected unit short. It's usually a new concept to students, and it's a hard one to get used to, so you should work through the problems to make sure you get a really good understanding. And the big thing that I think you should take away is that the loss function it's simply an expectation. You're finding an expected value where it's a discrete case or a continuous case, and you can tabulate the loss function for any distribution. And what we did is we tabulated it for the normal distribution, and so we found the unit normal loss function, this G sub k, which we will use a lot of in future lectures. And you can calculate it using the table, or you can use a spreadsheet. So those are the two big key points, but there's some even bigger takeaways that you might not have noticed. So what I have here is the demand distribution for our jerseys, and let's take the case where we allowed a salvage value of $7 per jersey per unit. And I found that my Q star here was equal to, if I'm not mistaken, 40,149. So here's my demand distribution, and my expected value is 32,000 jerseys, and we ordered just over 40,000, so let me just draw that up. This was our Q star for the case 2 that we solved. And so what I can say here is that for any demand that is less than Q star, this is when the probability of my demand is less than Q. Anytime this happens, I am in stock. I have enough jerseys for the expected demand. I'm probably not going to run out. Now, to the right, when the demand is higher than Q star, this is where the probability of my demand is greater than Q. And here, this is where I am stocked out. I will have a stock out. And so we've calculated this, but thinking about it a little more, what we've actually figured out is how frequently this will happen. Because remember, to figure this out, the probability that the demand is less than Q, what is that? That's the critical ratio that we determined. And that is the area under this part of the probability distribution. So we know that this was equal to 77%, because that was what our critical ratio was. So we're saying that 77% of the time, I'll have enough inventory. What this tells us conversely, on this side of the curve, this is the probability that I'm going to stock out. And it's going to be equal to 1 minus this critical ratio, or the probability that I don't. So 1 minus 0.77 in this case. So it's 23%. So by picking a Q star of 40,149, this is saying that 77% of the time I'll have enough inventory, but 23% of the time I will stock out. How many units will I expect to stock out? That's the expected unit short. So what we've done is calculated 2 levels of service, and we're going to be using these in all the other inventory models that we create in future lectures. These are the 2 big takeaways. The idea that we can now calculate the level of service, both in terms of the probability of stocking out at all, and then the expected units, number of units that I'm going to stock out. Okay, so that's it for this lecture. If you have any questions, comments, or suggestions, I encourage you to use the discussion.